everyone. Now that we are done with understanding the feature selection technique with the correlation method, time comes to relook into the data once again and try to understand a very important point. So what we should understand over here is, in this data frame, if you have a look, all of the features are having continuous values. Now think of another data frame, this, which is having majority of the features as categorical features. Now what is the technique that can help over here to do the feature selection? Because what we saw previously, that was correlation and that was useful for continuous features. So that's where we get the next technique, which is chi-square test. Now this video I'm going to split in two parts. In first part, I'm going to cover how would you calculate chi-square by hand or manually if you don't have any technology, because that is very important to understand the techniques or algorithm behind the syntax or codes which you are creating. Though the technology has simplified the work, but it is it is important that we understand the algorithm which is running behind it. That's where in the first part I'm going to cover the logic or algorithm behind chi-square, and in the second part I'm going to do the implementation in Python. If you are interested in only in second part, please feel free to skip the half of the video and continue watching the implementation in Python. Alright, let's just start. In chi-square test, to understand this, let's take a sample data, this, which has just three features: employment, education, and loan status. The last one is the target feature. First two are the input features. What we have to identify is the alternate hypothesis says that the education is influencing loan status, which means higher the education, possibility to get the loan is greater the possibility of getting the loan approved. So to evaluate this, what we do is we try to observe the count of this data and we come up with this kind of observation. In this data frame, you have 100 records and 3 features, 100 rows and 3 features. So when we summarize that, this is what we get. Now, if you see over here, for postgraduate, there are 18 approved, 9 declined, altogether 27 applications. Null hypothesis says, no, this is not true. The condition, whatever statement alternate hypothesis is saying, that is incorrect. So we come up with two statement. First, null hypothesis, which says there is no significant relation between education and the loan status. Second one is alternate hypothesis, which is represented by H1 or H alpha, which says that there is significant relation between education and loan status. This is what we have to prove through chi-square calculation. If you observe a word which is coming again and again, that is significant. What is this significant? So that is nothing but you can just consider a number which we have to specify that if anything which is coming greater than this, then we will go ahead with the alternate hypothesis, or less than this we will go with null hypothesis, etc. Anything which that's we can consider that it's a condition, right? So let's consider over here the significance level I'm going to consider, which is 0.05, which is the ideal situation. This is also called the p-value, right? This is an ideal situation where we usually take the significance level at 0.05, which is 5% also. Hope this is clear. Now let's move on and try to calculate the chi-square. Now, first of all, when we are proceeding with calculating the chi-square, we need to have a expected value for this observed value. This table which you are seeing, this is observed values or observed tables. We need to create another table which is having the expected value. Expected value is nothing but the probability of something happening. For example, what is the probability that 18 postgraduates will be approved? To find that, what we're gonna do is we're gonna take row total multiplied by column total and divided by grand total. Which values are those? Those are 27, which is row total for postgraduate, then 54, which is column total for approved. Then we are going to take total number of rows available in this data frame, which is 100, and ultimately we come up with this value, which is 14.58. Exactly the same thing we are going to repeat for each of the rows and each of the columns. In the next step, we will calculate for graduate, and for that we will do the multiplication of 24 into 54 divided by 100. So after doing this calculation, we come up with this table. What you observe over here is this is the value which we just calculated. Similarly, it is calculated for graduate, for approved, and same way it is calculated for decline also. Next step is to calculate the chi-square value. To calculate chi-square value, this is the formula which we use. Over here, if you notice, this O represents to the observed value. Observed values are something which are available over here. E represents to the expected value which are available over here. So what we are precisely saying is observed value minus expected value and divided by the expected value, and whatever we get, we need to sum up them all. Let me explain you this further. This is our observed values and this is our expected value, which we got using this formula. Let's move ahead and try to solve this. So when you try to solve, this is the table which you will get. Let's go by this table one by one. First column is observed values. So if you see from 18 to 6, that is given over here, 18 to 6. Then 9 to 7, that is given over here. So all the values, whatever the columns that you have, you need to put the value from each of those columns one below another. Same way you need to do it for expected table as well, expected values as well. So you see over here, these values are mapped against these values. It is very important. You should not be doing incorrect mapping, right? So this, let me help you understand once again. These all values should be subtracted from these values. That's something which we need to notice. So first one is observed value, second one is expected value. Here comes the difference, observed minus expected, and this column contains the squared of this difference, and this column contains a squared value divided by again the expected value. And when we sum them up all together, what we get is 3.62. This is called x, not x square, but the chi-square calculated value. We just got chi-square calculated value. There is another value which we need to find, and that is x square tabular, which is chi-square tabular value. To find that, what we require to have is degree of freedom. Degree of freedom is nothing but the option. It simply says that how many options that you are left with to move ahead. To find that, what we do is number of rows in the expected table minus number of rows minus 1 into number of columns minus 1. So over here you see, either here or here, doesn't matter, either in expected table or in the observed table. What we require to consider is this area into this total column. We don't need to consider. So you see how many number of rows that we have, 5 minus 1, which will be 4, and number of columns that we have is these two, approved and declined. You don't need to consider this education. Okay, number of columns minus 1, then we are left with 1. So this is the number which we get, which is 4. Degree of freedom that we have is 4. Now for this, we need to find the chi-square tabular value. To find that, what you need to do is simply go on Google and try to search chi-square distribution table, and you can open any of these. I have just opened the first one. Before we try to dive into that, let's just understand we require two values to look for a chi-square value in the table. For that, first one is degree of freedom, and second thing which we require is significance level. Significance level we have 0.05, and degree of freedom we have 4. Let's go to the table and try to find degree of freedom. Here we got 4, and significance level over here 0.5. You see, this is the intersection of both of these two, which is 9.488. So this is what we got. This is the value for chi-square tabular. Now we need to compare both of these two, chi-square calculated and chi-square tabular. If you see, chi-square calculated is less than chi-square tabular, which means the alternate hypothesis is rejected. This rejects the alternate hypothesis, which means null hypothesis is true, and that means ultimately that there is no relation between education and the target feature, which is loan status. There is no relation. The education is not influencing the target feature. This is what the hypothesis, this chi-square calculation makes. I hope this is clear to you. In case of any doubt, put that into the comment section. Now, what does this mean? I just explained that here the education is not having any significant relation with loan status basis on this calculation or basis on this analysis. I hope again that the calculation method was simple enough to understand it. In the next step, I'm going to take you to the Python, and over there I'll show you how to implement this on data. Here in Jupyter Notebook, before we start further, you need to make sure that these all dependencies are available, installed, downloaded, or whatever you want, and imported properly in this session. Now here is the data that I'm going to use. I will upload this data on GitHub and will share the link in the description section. You may feel free to check that out. Next thing which we need to do is, out of this data we need to find all those features which are categorical. Like you can see, some of them are numerical, but we are going to be focusing on categorical only. Okay, now so for that categorical, I am going to take senior citizen. I see this is also categorical, but for now I will not focus on this. I'm going to look on only those features which are having the alphabetic values. Okay, now let me just very quickly say categorical cat features equals to df dot select data types, and over here I'm going to say include, and out of this include, what is it that we want to include? We want to include, come on, tell me very quickly. We want to include object. All right, and now let's just see what is it that we got over here. We got all those features where it is object. These are the categorical features. We don't require this customer ID, so I will quickly drop it. And here I would say access equals to 1. That is done. We are done with finding this one. Now the next step, let's very quickly check whether either of these feature are having any missing value or not. Is null dot sum. So none of these features are having any missing value. That's a good news. Moving on, what we will do is we require to convert this all, because the model will not understand these character values. We require to convert it into numbers. So for example, if you see, let's just try to find the unique values. Which feature is having how many unique values? Okay, cat features dot n unique. All right, total charges, my god, total charges are having 6,531 different values. I'm not sure what those values are. Let's just have a look on that. Cat features dot unique, sorry, total charges dot unique. Oh, categorical features, I don't think this total charges is needed, because this seems like a continuous feature, isn't it? So we will drop that also. That is not needed, though, because of some data type issues and etc. That is coming over here. So I will include this also over here. That's a continuous feature, and should not be treated as categorical feature. That's a data type issue, that's why it is coming over here. So if we are implementing the models, that will come in the data cleaning part, which I have skipped over here because here we need to focus on chi-square. Now we are done with this. All right, then you see the maximum unique value, the feature which is having the maximum unique value is 4. Looks pretty good. Next thing which we need to do is convert this all into numbers, either 0, 1, 2, 3, etc. So for that we have label encoder. Label encoder we have already imported. Where can you find that label encoder? That is available in sklearn pre-processing. Here is the label encoder. Next one, I'm going to create an instance for this label encoder. Next, I would say encoded data frame. I'm going to create pd dot data frame encoded, and here I would say for column in categorical features dot columns. So here I'm simply taking the list of all the columns from categorical features and iterating through each of them. Encoded, here I will create another column, and over here I would say label encoder dot fit transform, and inside that I can just put call. Let's just see what is the error. Why should be 1D array got 2D arrays? What's the challenge? It should not be. All right, I made an error here. It should be like this. Method object is not subscriptable. What's the issue now? All right, so it should not be, it should be like this. Why I'm making such a silly mistake? Cat features. Now this is done. Encoded dot head. Super, we got our values encoded. Next one we are going to be, next we need to split this data in train and test split. So there is another method, not method, but this module which we need to use, train test split, that you can import from sklearn model selection. Over here what I'm going to say is train test split, and into this I'm going to provide the data encoded. So out of this we need to exclude this target feature, which is churn. This is the target feature for us that I need to just exclude from the input. So first we need to supply the input, then we need to provide the target, both of these two things, right? So over here I'm going to say encoded.drop, and inside that this column is something which I want to drop, which needs to be looked on axis number 1. That means column. Now over here I need to use encoded, and out of this I only require this particular column. Test size I need to provide, I'm going to keep 20% of the data as test size, and then random state I'm going to use 42. You can use anything, but if you want to get the result same as I have, then please use this proportion. Okay, now over here I need to create xtrain comma xtest, and then ytrain comma ytest. This is done. Let's have a look at xtrain data dot head. They should not be having the churn column into it. You see, it is not having that. Now we are pretty good to calculate the chi-square. Chi-square over here, and inside that we need to supply xtrain. Remember, to do any sort of this feature selection analysis, you should always perform that on xtrain only. Though when you are eliminating those features or keeping those features, you would require to do that on both of the set, which means on training and testing both of the set. But when you are doing the analysis, you should be performing that on xtrain only to avoid overfitting or data leakage. You can also say xtrain comma ytrain, and I'm going to put it in chi-score data frame, rather you can say, okay, or the feature. So here is what we got. So you see it is a two-dimensional array. Into this, first one is showing you the chi-square value and second one is showing you the p value. So which one to keep and which one to drop? So greater the score for chi-square is better for us and lesser the p value is better for us. So what we need to find is, this is showing the relation with your target feature, not with each of the feature. Remember, in correlation we were trying to find the relation between each of the feature and with target feature also, but over here it is taking each of the feature and trying to find the relation with target feature. So hope that is clear. Now let's just move on and try to visualize this. Okay, so here I'm going to say chi-square square chi-square score dot chi-square dot index. No, not this. We need to convert this into series, right? Because currently it is array. We need to convert this into this series. So how can you do that? So for doing that, you need to say pd dot series and inside that the first element we need to grab after out of chi-score, and that is 0, and then we need to supply index value we can directly take from xtrain dot index, and let's just say chi-square score underscore series. Alright, same thing we will do for p value also. Over here I just need to make 1, that is it, and over here I can say p value, let's keep it in small letter only, p value series. Looks like it is done. Chi-square score series, this is what we got, and then p value series, this is what we got. I will also do the sorting of this data. Sort values, ascending equals to false because I want to keep that in descending order, and over here I would say sort values, and here I would keep it in ascending order because we need to see the smaller one at the top. Now this is done. After this, what we require to do is we need to do the visualization. All right, this does not look correct. Here I need to say columns. All right, everything is having same sort of feature, same sort of chi-square value. How could that be possible? Alright, I had made a mistake here. The variable previously which I had was chi-square score, right? While originally which I had created was something else, right? So that's what I just changed. I have taken this and I'm putting it over here, and then you see this is the data which I got. All right, if you want to round it, you can do the rounding of it also. I'm going to keep it keep this as it is. Now I will quickly try to plot it using SNS is nothing but the Seaborn library. Let me see if I have imported it all. Not, I'll quickly import it. Import Seaborn as SNS, import matplotlib.plt as pyplot. Done. matplotlib.plt. What's wrong? No module name. Matplotlib. Why is that so? Let me see. We can do. All right, the challenge was here. I was right. I had written plt. Ideally I should write pyplot. Okay, now let's just come down over here, and again I'm going to say his plot, and on x-axis I'm going to put index Next on y-axis, I would put why I'm using p-value. Rather, I should be using this one, isn't it? Yes. And then over here, dot values. And this is what we got. Now to make it look better, okay, and let me just show you this data also first. You see, now this is readable. So what you see in this data is, this is the most important feature. It is having a great relation with the churn feature, which was our target, and this is also is having great relation. All these three are appearing to be having great relation with this, with the target feature. Now over here you saw, this is how we have plotted it. To make it look good, I'm going to do quick thing, plt dot figure, and inside that fig size, and I would say, 15 comma 5, and here I would say plt dot xticks rotation, I'm going to keep it 90 degree. Now you see this is looking pretty clear. Over here what you see is this first one, contract is having the highest relation, highest score. That means that is the most important feature. Okay, then these two, then this one, right? So approximately these four are showing relatively the great relation compared to the rest of them. So rest of them is something which you can feel free to drop or not keep while you're training, or maybe you can do the simulation. And over here, these are the features which are most important. My recommendation will be to go ahead with these three features, right? All that you require now to do is just simply drop these features from your data x train data frame, and then utilize that in utilize remaining data in training your model. Okay, now over here let's try to plot the p value as well. Let me see if this is going to work. Over here, let me see if both of these two can come. So this appears to be, let me put that in a separate one. It's not coming over here. And let me put this over here. Again, the same thing I will put over here as well. All right, now what you see over here is, again, it is showing the similar result, right? It is showing the similar result, means this was in ascending order. So these are the features which are having least p-value, and these are the same are the features which are having the highest chi-square values. So you see both of these two are quite in sync. So yeah, the analysis is pretty well. You can just go ahead and drop this, I mean, you can just select these three features to train your model, and you can go ahead with the implementation. So here I'm not getting into training the model and testing it. I'm keeping it simple to the feature selection only. Let me know if you'd like me to cover that part also in each of the feature selection video. Okay, thank you very much for watching this. Wish you very